Assalamu alaikum students, I hope you all are doing well. Today's topic is addition and subtraction of matrices. So let's see addition first. The definition is if A, the matrix of order m into n, and B, matrix of order m into n are two matrices of the same order, then their sum A plus B is a matrix and each element of that matrix is a sum of the corresponding elements. So basically the idea is if we have two matrices A and B, suppose A is of order 2 by 2, elements are 1 2 3 4, and B is of the same order, means 2 by 2, 2 rows 2 columns, and we add these matrices. When we have to add these matrices, then we will add up the corresponding elements of the two matrices, means the element at first row and first column of A will be added to the first row and first column element of the B. Same for the other elements. 1 will be added to 3, 2 will be added to 1, 3 will be added to 4, and 4 will be added to 1. So the answer of A plus B will be a matrix of order 2 by 2. Obviously the order will be remaining same. 1 plus 3 4, 2 plus 1 3, 3 plus 4 7, and 4 plus 1 5. So this is the simplest way of adding two matrices. You can add more than two matrices as well, 3 or 4, but they should be of the same order. Now let's move to the properties of matrix addition. There are some properties to be considered for matrix addition that are follows. If A, B and C are matrices of the same order, then the first property is for commutative law, as we have studied for sets as well. A plus B is equal to B plus A, means if we change the order of addition of the matrices, if we add A plus B or we add B plus A, if we add B to A or A to B and the matrices are same, so the answer would be same, they will be equal. This is commutative law. The second one is associative law. In associative law, three matrices will be included, A, B and C, and this law says if we firstly add two matrices A and B and then we add C, so it will produce an answer. You may call it X, okay? And then if we add B plus C first and then to that answer of B plus C we add A, and it produces Y, matrix X and matrix Y, so they will be equal, because no matter what the order is, the matrices should be the same and they should be added only. The third property is identity of the matrix. Let me clear the board. Okay, so the third property is identity of the matrix. This property says that if we add a null matrix to a matrix A, then it will be equal to the answer of that matrix in which we are adding A to the null matrix, where O is a zero matrix, which is the additive identity of the matrix. It is same as if we add 0 to any number, like 1 plus 0, the number will remain same 1. If we add 0 to 1000, the answer will be 1000. So it is the additive identity. 0 O is here the null matrix, 0 matrix, whose all the elements will be 0 0 0. So the answer will be A, the matrix itself. Let me clear it with an example. Okay, so if we take a matrix A, 1 and 10, and we add a matrix O in it, and matrix O has two elements 0 0, You have to remember this thing, that the order of the matrices should be same, always the same, for either subtraction or addition. The order of A is 1 by 2, and for O, or the 0 matrix, 1 into 2. Okay, because there are 2 columns and 1 row, 1 row and 2 columns. So the basically idea is that if we add a null matrix O to any matrix, then the answer will be the actual matrix. Because if we add 1 plus 0 and 10 plus 0, means the corresponding elements will be added, so there will be no difference in the resultant matrix. By adding 0, the elements will remain the same. Okay. Furthermore, the thing mentioned here is, if we add 0 matrix to A or A to 0 matrix, the answer would be the same, obviously, commutative law. And the other thing is, the answer will always be equal to the actual matrix A. Okay. Now the fourth property, additive inverse. By additive inverse, what we mean is that if we have a matrix A and we add a negative of A, means the same matrix, but we change the sign of the elements of that matrix, and we add those both matrices, then the answer will be equal to 0. Let me tell you with an example by a simple number. Like if we have a number 1 and we add negative 1 to positive 1, then the answer will be 0. Same is the case that if we have a matrix Z, and we add negative Z in positive Z, then the answer will be 0. Means the resultant matrix will be null matrix, depending upon its order. Okay. Let me give you an example using 2 matrices. Okay, so we have a matrix Q whose order is 1 into 1, because 1 column, 1 row, only one element, 1 or maybe 10, and we convert this Q to negative Q or minus Q by changing the sign of the single element, that is minus 10. And when we will add Q plus minus Q, then the answer will be what? 10 plus minus 10. So the answer will be 0 matrix. So the answer will be 0 or null matrix, because 10 minus 10 will be 0. So this is the property which is called additive inverse. For any matrix, the additive inverse of that matrix will be the negative matrix. And how we will achieve the negative matrix? By changing the sign or sign of every element of the matrix. Okay. Now the fifth property is that if we add 2 matrices, if we add or subtract, but as we are studying at addition of matrices, so I will go for addition only. If we add 2 matrices A and B and we take its transpose, and on the other hand we first take the transpose of matrix A and then transpose of matrix B, and then we add those 2 matrices after taking their transpose, then the answer will be same as when we firstly added 2 matrices and then we took transpose. Like it doesn't matter if you take transpose before adding the matrices or after getting the result by addition. Let me give you an example so that you can understand in a better way. Okay, so we have two matrices A and B. A is equal to 5, 7, 2, 3. B is equal to 0, 0, 1. Okay, now let us take transpose of A. In transpose, what we have to do, that we have to change the order in a way that we change column into row and row into column, like column into row. This column will be the first row. First column will be equal to what? First row. Like 5 2 is the column, so we'll write 5 2 as a row, and 7 3 is second column, so second row will be 7 3 for transpose. Okay, and for transpose of B, which will be 1 0, because first row first column will be as first row of transpose, and 0 1. Okay, so this is the transpose. Now as we have got the transpose, let us prove the property. So for the left hand side, we will add A plus B. A plus B will be equal to 5 plus 1 6, 7 plus 0 7, 2 plus 0 2, 3 plus 1 4. Okay, and now if we take its transpose, it will be what? 6 2 7 4. Now we have to add these two for right hand side, transpose of A and transpose of B. So by adding this, the answer will be 5 plus 1 6, 2 plus 0 2, 5 plus 1 6, 2 plus 0 2, 7 plus 0 and 3 plus 1, 7 plus 0 7, and 3 plus 1 4. So this one. So see, we have these two matrices, this one for left hand side and this one for right hand side, as they are equal, 6 2 7 4 6 2 7 4. So the property has been proved that if we take transpose of the resultant matrix by adding A plus B, or if we take the transpose before adding the two matrices, then the answer will be same. Okay, equal. Now we have the last property for addition. It says if A plus B is equal to 0, then it will be equal to B plus A. Then B is called the additive inverse of A, and also A is called the additive inverse of A. It is very simple idea that if we add A plus B and the answer is 0, okay, and if we add B plus A and then the answer is 0, so the A plus B is equal to B plus A, it is commutative property, and it leads to the another property that if the answer is 0, so the one matrix is the additive inverse of other matrix, because by adding that matrix to the first matrix we get the answer 0, we get the 0 matrix. So for if A plus B is equal to 0, then B is the additive inverse of A, and if B plus A is equal to 0, then A is the additive inverse of B. Okay, both can be the cases. Okay, so at last we have subtraction of matrices. It is same as addition, but just the difference of operation is here, that firstly we added the elements, corresponding elements, now we are going to subtract the corresponding elements of the matrices. And all the previous idea are the same, that order of the matrices should be same and everything else. The difference of operator is here, that is minus operator, so the elements will be subtracted, and we have to find the difference, of course. So let us read the definition first. Definition says if A and B are two matrices of the same order, then we can subtract the matrices by subtracting each element of one matrix from the corresponding element of the second matrix. Okay. For example, if we have two matrices x and y, x is equal to 1, 2, 3, and y is equal to 4, 5, 6. Okay. So the order of x is 3 into 1 because 3 rows and 1 column, and for the y there is same order 3 into 1 because 3 rows and 1 column. So now what we have to do, we have to subtract y from x. So let us find the answer. 1 minus 4, corresponding elements will be subtracted. 4 will be subtracted from 1, 5 will be subtracted from 2, and 6 will be subtracted from 3. So the answer will be 1 minus 4 minus 3, 2 minus 5 minus 3, 3 minus 6 minus 3. This is the only coincidence that we have got minus 3 minus 3 minus 3 at all three positions, and this is the answer. Okay. Okay, so this was our topic, and one more thing, that this property E is also applicable on subtraction as well, because it says that if we take transpose after subtracting two matrices from each other, then the answer will be same as we have if we have taken the transpose of A and B before subtracting them. I can explain it with the example. Let us finish it with a very clear example for the property E of transpose for subtraction of matrices. So we have two matrices, matrix A and matrix B. Let us find A plus B first. A plus B will be 2 plus 1 3, 4 plus 3 7, 3 plus 2 5, 4 plus 4 8. Let us take its transpose now. It will be 3 5 7 8. This is our left hand side answer. Now let us find right hand side. So we will take transpose of A. It will be 2 3 4 4. Transpose of B equal to 1 2 4. Now let's add these transpose of A plus transpose of B. Let's see the answer. 2 plus 1 3, 3 plus 2 5, 4 plus 3 7, 4 plus 4 8. So this is the right hand side, and it is same as left hand side. See, they are same, equal. So we have proven the transpose property for subtraction as well. So this was our lecture for today. I hope you have got a point, and if you have any question or query or confusion, you can ask me in the comment section. Thank you so much. Allah Hafiz.